You wake up tomorrow morning. You open the curtains, and the sky is the wrong color. Not the pale blue of a clear day, not the orange of sunrise. Electric, blazing, impossible blue. You look up, and the sun is blue. Not slightly blue, intensely, blindingly, terrifyingly blue. And in that moment, before you even understand what you're seeing, your skin starts to burn. Before we continue, your question for today: if the sun turned blue, a blue star burns out much faster than our sun, how long would it last? Drop your answer in the comments. New here? Subscribe. This is where we break the universe with real science. First, what does a blue sun actually mean? A star's color tells you everything about its temperature. This is called the blackbody radiation spectrum, and it's one of the most fundamental relationships in astrophysics. Red stars, cool, around 3,000 degrees Celsius. Yellow stars, medium. Our sun sits at about 5,500 degrees. White stars, hot, around 10,000 degrees. Blue stars, the hottest objects in the observable universe. Surface temperatures between 10,000 and 50,000 degrees Celsius. So when the sun turns blue, it doesn't just change color, it becomes a completely different class of star. Hotter, more energetic, more powerful. Radiating not just visible light, but vastly more ultraviolet radiation, X-rays, extreme energy in every direction. The sun turning blue isn't a cosmetic change. It's the difference between a campfire and a nuclear reactor. The changes begin before most people even wake up. The increased UV radiation hits the upper atmosphere first. The ozone layer, Earth's primary UV shield, begins breaking down within minutes. Not years, not decades, minutes. At 50,000 degrees, the UV output of a blue star is thousands of times more intense than our current sun. The ozone layer doesn't thin gradually, it's overwhelmed instantly. By the time the first person steps outside to look at the blue sun, they are standing under open sky with no UV protection whatsoever. Exposed skin begins burning within seconds. Not sunburn as we know it, the slow reddening of a beach afternoon. Immediate, severe, deep tissue damage. Eyes, without protection, begin suffering corneal damage within minutes of direct or indirect exposure. The light itself, shifted into frequencies the human eye wasn't designed to process, appears simultaneously brighter and wrong. Disorienting, painful, the most beautiful catastrophe anyone has ever seen. Within hours, global communications begin failing, not because of bombs or cyber attacks, because the intensified solar radiation triggers the most powerful geomagnetic storm in recorded history. The magnetosphere, overwhelmed by the energy output of a blue star, fails to deflect the incoming charged particles. Every satellite in low Earth orbit fried within hours. GPS, gone. Internet infrastructure dependent on satellites, gone. Power grids across the planet begin failing as geomagnetic induction currents surge through transmission lines. The same phenomenon that causes the northern lights, now strong enough to melt transformer cores. Within 72 hours, most of the world's electrical infrastructure is destroyed. Not damaged, not disrupted, destroyed. And without power, water treatment stops. Food refrigeration stops. Hospital life support systems, running on backup generators with limited fuel, begin counting down. The blue sun didn't launch a single missile, didn't send a single soldier. It simply changed color and dismantled civilization in less than a week. Beyond the immediate human catastrophe, the planet itself begins changing. A blue star radiates roughly 10 times more total energy than our yellow sun. Earth's energy balance, the careful equilibrium between incoming solar energy and outgoing heat radiation, shatters. global temperatures begin rising immediately, not the gradual warming of climate change measured in fractions of a degree per decade, degrees per day. The oceans begin absorbing energy faster than they can release it. Surface temperatures in tropical regions climb past 60 degrees Celsius within weeks. The water cycle accelerates dramatically. Evaporation rates surge. Massive storm systems fed by unprecedented ocean heat form and intensify faster than any hurricane in recorded history. Category 6, Category 7, categories we don't have names for yet. The atmosphere becomes a pressure cooker, and the ice caps, already stressed by decades of warming, collapse within months. Not melt, collapse. Here's where the science delivers its most unexpected answer. Under a blue sun, most complex life on Earth's surface dies within months. Plants, which evolved to absorb yellow and red wavelengths, cannot photosynthesize efficiently under blue star radiation. The wavelengths are wrong. The intensity is lethal. Forests collapse. Agriculture fails. The food chain from the bottom up dismantles itself. But deep in the ocean, something different happens. Below 200 meters, UV radiation cannot penetrate. The deep ocean remains, at least initially, a refuge. Hydrothermal vent ecosystems, which don't depend on sunlight at all, continue completely undisturbed. Chemosynthetic bacteria, deep-sea creatures, life forms that have never needed the sun, surviving the sun's most dramatic transformation. And some microorganisms on the surface, extremophiles that live in high UV environments, might not just survive, they might thrive. Evolution doesn't mourn what dies, it works with what remains. A blue sun doesn't end life on Earth, it restarts it from the bottom. Blue stars are the most spectacular objects in the galaxy. They burn at 50,000 degrees, they shine with the energy of 1,000,000 suns. And they die young. Where our sun has been burning for 4.6 billion years and has another 5 billion left, a blue star of equivalent mass burns through its fuel in a few million years. Brilliant, intense, brief, like a flame turned too high. Our sun will never turn blue. It doesn't have the mass. It will live its quiet, yellow, medium temperature life for another 5 billion years, giving us time, giving life time to grow, to evolve, to reach for the stars, including the blue ones. So the next time you see the sun, yellow and warm and ordinary, remember, ordinary is the rarest gift in the universe.